Welcome to Next in Tech, an S&P Global Market Intelligence podcast where the world of emerging tech lives. I'm your host, Eric Hanselman, Chief Analyst for Technology, Media, and Telecom at S&P Global Market Intelligence. And today, we're going to be talking about the next stage of a lot of what's happening with data center technology, some of the gear that's actually inside the data center, and what's going on there with Perkins Liu. Perkins, welcome back on the podcast.
Thank you, Eric.
It's great to have you back, and you've been to the Open Compute Project conference and have been part of all of the discussions that were going on there in terms of a lot of new standards, new equipment, new capabilities, and I think a tie into some of the things we've been looking at in terms of AI's impact. But I wanted to start off first with just a little background on the Open Compute Project. Can you let our listeners know really what is Open Compute doing? What's its history? Where have they come from in terms of what they're actually trying to accomplish?
Yes, absolutely. The OCP Foundation was initiated in 2011 by that time Facebook, now Meta, with the mission to take advantage of open source and open collaborations to speed up and foster the hardware innovation, starting from the core of computing, including servers, storage, and network equipment, to the supporting racks and the entire data center infrastructure. The inspiration specifically came from Facebook's design and construction practice of its hyperscale data center in Plainville, Oregon, where a small group of engineers gathered together in 2009 and spent next 2 years designing and build a data center from the ground up: software, servers, racks, power supplies, and cooling. The data center was 38% more efficient in terms of energy to build and 24% less expensive to run than the company's previous facilities. So this OCP concept later on quickly expanded to the entire industry ecosystem, not just inside the Facebook company itself. Microsoft joined the OCP in 2014, Apple joined OCP in 2015, and Google joined OCP in 2016. You see all the big players there. Now, there are about 325 member companies, including the names we all know: ARM, Meta, IBM, WeWin, Intel, Nokia, Google, Microsoft, Dell, Rackspace, HP, NVIDIA, Cisco, Goldman Sachs, and Fidelity, Lenovo, Baidu, Alibaba, Tencent. The name goes on. So, though starting from hyperscale data centers, OCP outgrew its roots, bringing the collaboration model to non-hyperscale and edge data centers, and further to the telecom industry. So as of today, there are 14 technology and strategy projects and 6 regional projects under OCP. Some projects also have sub-projects, such as the Data Center Facility Project, their modular data centers, OCP Ready Facility Recognition Program, and the Operation Technology Security and Sustainability sub-projects. In the cooling environment project, there are sub-projects of like immersion, cold plate, door heat exchanger, and advanced cooling facilities, and heat reuse. Some of the innovation solutions OCP published include a 48-volt DC power shelf for the whole rack to feed individual servers in the rack in place of the traditional power supply in each server. So that's a brief introduction of the OCP organization, and OCP held its annual summit in San Jose.
Well, it's interesting. I think you hit on what is that core piece of the effort to build an ecosystem. Back when this was founded, the idea that you could actually build data centers differently, because what typically had been happening is we took regular chassis-based servers. Everybody, there were already rack mount servers. And everybody was racking and stacking and taking standard kinds of equipment and building data centers with it. But that the hyperscale model was really something that was changing. And what, back at the time, Facebook wanted to do was create an ecosystem of providers and expand all of the participants so that there would be a broader market to provide what were these, at the time, very cutting edge transitions in terms of capabilities. As you said, DC power, the fact that at the time, everything was run on, you'd run regular AC power to the individual racks, but you could actually save energy by reducing the number of conversions that you made from the actual external supply power, the step-down transformers, and in fact, eliminate one big step if you actually just brought the DC power without doing the initial step down from like the 480 volt AC power and actually bring that right in on DC and have all sorts of all sorts of improvements in terms of that. But you had to have a set of manufacturers who are willing to do that. And this is the thing that I think is the interesting piece about this sort of next shift that's happening with cooling capability. And I guess some of this we've seen, I know we've been talking with Dan Thompson and Nick Patience about greater density and some of the impacts that AI happens to be having. I guess we've kicked around the idea of whether or not there is something that is an AI data center, but AI is having some impact on data center design, at least in some forms, yes?
Yeah, absolutely. So probably we talked a little bit more about AI, the chips itself, with Nick Patience and all the other experts on that topic, but to particularly look into the impact to the data center. Yes, what we see here is the faster growing generative AI requires a sustainable, large scale computational infrastructure and brings all around new challenges or accelerates and intensifies some of the known challenges that from the work we have on the HPC applications. The most noticeable challenge is the increasing power density. Since the wide use of GPU for AI application has pushed the power consumption of the servers dramatically. We all know that a key indicator of the chip power density is thermal design power, or TDP. Even for the GPUs, the TDP has been marching toward 200 watts from 100 watts for a decade. Until recently, 2020, it has shown signs of acceleration in the past 3 years and approaching 400 to 550 watts. And on the other hand, NVIDIA's GPU chip started from 200 watts as early as 2009 and reached the 400 watts. It's A100 in 2020 and 700 watts. It's H100 in 2021. And the next generation GPU is expected to go over 1,000 watts. This B100 model. So when the chip TDP enters the 200 to 300 range, in terms of cooling, special airflow management together with the increased fan volume and the velocity is required to take the heat away quickly enough. But when the TDP reaches 350 to 400 watts, it becomes much more complex and costly to cool the server using air. Most of the time, a higher and a larger heatsink is required to increase the available area for air cooling. An air-cooled server of H100 GPUs could take up to 8 U space. But in comparison, a direct-to-chip liquid cooling server takes only like 2 U space. And during the operation, the very powerful fans are usually required to run at the full speed, which is very noisy.
Mm-hmm.
So we all know when TDP goes even higher, no matter how intense the fan is, the speed of the heat transfer by air cooling can't catch up with the speed heat is generated. Therefore, people have to seek an answer from liquid cooling. And on top of that, the specific AI HPC application requires a GPU to be placed as close as possible from a network perspective to achieve a cluster effect. So for both reasons, long story short, a data center for AI application is going to be very, very high power density, and we would have to turn to liquid cooling to seek the answer to cool the data center.
Yeah, and it comes down to a matter of physics. It's just that issue of you've got to be able to take away all the heat that's being generated. And when you get to higher powered devices, you mentioned, NVIDIA started out at a higher level than most typical CPU processors, Intel or AMD processors, and has continued to grow. When you get to those densities, being able to move heat starts to become a real challenge because air has got finite heat capacity. But you look at liquids, typically water, they've got higher specific heat. You can put them in direct contact with devices. And now you can start to move that heat off the device and cool it more effectively just because you've got the ability to manage that. I'm curious what was happening with liquid cooling at the OCP conference, because I think one of the discussions has always been, how do you standardize? Because now you're having to go move whatever that cooling liquid is into and out of the device itself. There's a whole bunch of plumbing that has to get done with that. And I guess actually, before I get too far along, I think I wanted just to point out there is water cooling, because we talk about water use in data centers, but typically that's been to cool the air that's being moved around. In that, you've either got evaporative cooling, that's simply evaporating, taking water, evaporating it, and using that energy release the evaporation takes to be able to cool the air that's moving through it.
Mhm.
We move them through chillers, what we typically see in sort of air conditioning systems. But when we're talking about liquid cooling, this is actually plumbing the liquid directly into the server environment itself. So you can actually you talked about cold plates, things that are actually running that liquid right against the device itself. What was happening at OCP about that?
Yeah, so I guess to answer that part, we should go back to just to clarify a little bit of the concept of the liquid cooling and talk a little bit about what's happening in terms of liquid cooling in the data center space. So actually, liquid cooling is not something really new. That people have been using it in the data center for over a decade, believe it or not, but it's still in its infancy in the industry, since air cooling can still handle the majority of the cooling challenges in data center operations. Plus, as you mentioned, Eric, chilled water is widely used in the data center as the source of cooling at the primary loop, right? Which then takes the heat away through the exchange with the cooling units at the secondary site, which is close to the load of the servers. So when we say air cooling or liquid cooling in a data center, it's specifically about the cooling methodology used to cool the chips inside the servers, right? Whether the chip is cooled by using fans to blow air across the heatsink on top of the chip, or the heat is taken away by liquid through the contact with the chip. So that's the fundamental difference, air cooling or liquid cooling. Now,
So,
yeah,
I was going to say, why has there been more use of direct cooling?
simply the answer is that the air cooling can still do the job. The majority of the computer capacity is still general purpose computing or storage with a rack density at the range of like even climbing up to today's like 10 to 20 kW. Air cooling can still handle most of the challenge with some airflow management or speed up fans. But when the load density picks up, it runs into roadblocks. But right now, the majority of workload is still at this range that air cooling can handle. The extreme application like AI, HPC has a high density, high power density requirement.
Yeah,
So you get back to that, I should explain a little bit what we have in terms of liquid cooling. So liquid cooling, it can be divided into two major categories, direct to chip or immersion, based on how the liquid interacts with the heat generating electronic components. In a direct to chip configuration, fluid is not directly contacted the electronic components, but the liquid coolant is pumped to cold plates in place of heat sinks on electronic components in an air cooling configuration, where most of the heat is taken away by the cold plates. Fans are still needed to help remove the heat at the board level, but at a very low volume and the velocity in some cases. But
so it's usually a mix of both air. You're taking the really hot components,
Yeah,
cooling them down with direct-to-chip, but still need air to be able to keep the rest of the componentry cooled off.
that's right. And the liquid is running through a pipes. But in comparison, in an immersion cooling configuration, fluid is in direct contact with everything, with all IT equipment. As the equipment, the server board is immersed in a dielectric fluid. The heat generated is then directly dissipated into the liquid surrounding it. So there's no fans completely. So that's the fundamental difference between these two types of liquid cooling, and they require the architecture a little bit different from the traditional racks.
Yeah, I mean, it seems like between the two of them, with direct-to-chip, with cold plates, you actually have to have the plumbing that runs into the chassis and gets to the chip, which has its own complexities. With immersion, you've actually got to take the entire board and get it immersed, which sounds like could be even more complex.
Yes, so whether it is direct-to-chip or immersion, a certain level of modifications to the servers, to the rack, and even to the infrastructure facility at the white space is required. Someone would have to take the heatsink out and replace it with either a cold plate or get rid of all the fans, and to bring CDUs and a manifold to the rack to feed the liquid to each server through the pipes connectors. And in an immersion cooling configuration, we cannot leverage the traditional rack architecture anymore, right? But I have to put the servers into a tank. So all this will need an extra engineering work in design, construction, and even operation habits. So while the data center industry has comfortably established its standards and interface between the system and the players around air cooling for decades, the emergence of liquid cooling brings the challenge of redefining and reestablishing all kinds of standards and working habits. So that's why we see liquid cooling has been used strictly in the HPC application or data mining application until recently. But with the wide adoption of AI, the fast increasing power density in data center and the scale of volume will force more data center operators turn into liquid cooling to seek answers simply because the workload, the power density is going up.
Yeah, densities are such. I mean, you've talked on a number of these particular points. You get to have smaller systems, saves on space, allows you to deal with these higher density devices. So, what's happening in the industry around direct to chip?
Direct to chip, as we can see, is that specifically into this OCP summit, what we sense is that industry has been exploring liquid cooling for a long time. And from chip manufacturers to server vendors to infrastructure suppliers, all have been involved. Particularly on this summit, on the exhibition floor, server manufacturers, ODMs, system integrators, including the company like WeWin, Pegatron, Supermicro, Emperor, Everest, OCT, Hive, and Gigabytes, all these guys, all have demonstrated their liquid cooling ready server rack solutions without exception. There are variations in server configuration, but most of the racks are capable of handling 70 to 100 kW rack density using a direct-to-chip liquid solution. In terms of this heat dissipation, there's a liquid-to-air heat exchange option that can dissipate the heat into the white space if you don't have a primary chilled water loop or a CDU coolant distribution unit that enables liquid-to-liquid heat exchange, that the primary loop chilled water takes the heat away. So the entire ecosystem is getting there ready. So data center infrastructure manufacturer like Delta, Rittal, Liteon, and all these guys all have brought a similar solution to the floor as well. So what we sense is that hyperscale guys are the drivers behind all this, and they're preparing for their next generation computing infrastructure, as they can foresee that using liquid cooling to support their increasing power density in the scale deployment is coming. So that's why all these guys are presenting their solutions on the floor.
Wow. When you start talking about 70 to 100 kilowatt rack environments, I mean, that's, just by comparison, we typically think that getting to 30 kilowatts is pretty high density, but that's really taken it up pretty significantly.
Yes, absolutely.
So, what should organizations be thinking about around liquid cooling in the year ahead? Are there things that they should be planning on? What are really the considerations when you start looking at what's out there and what the possibilities are?
Yeah, so in terms of cooling, there's a lot of options. Even for air cooling, there's many, many options, many, many like selections. So, simply for a business of if you want to consider around the liquid cooling, you need to take several factors into consideration. First is your business needs. So what kind of IT setup or IT gear selection you have, whether these are majority CPU based servers or it's going to be GPU based, what's the mix? And then second, what is your like typical density, whether it's a still traditional 10 kW-ish or around the density, or so there will be some specific applications goes up to like a 30, 50, even higher density, whether it's absolutely a requirement for liquid cooling. And the IT gears or off-the-shelf products, or it requires some level of custom design that extra work, extra cost is going to be involved. And the next is where are you going to put all these IT gears and the related infrastructure to support it, whether it's going to be installed on-premise data center or in a co-location space, right? Then when you look into the facility, is the facility ready to accommodate a liquid cooling solution? Whether it's designed as the traditional rack-based architecture or some level of retrofit is needed, or if not, right? And then what is your company's strategy and how you prioritize between these different goals for your business, whether it's TCO, it's efficiency, sustainability, and your aggressive level of adoption of advanced technologies, and as well as your tolerance to the risk. These are all a mix of aspects that a business has to take into consideration when they make a decision on whether they're going to use liquid cooling for the data center or not.
And it sounds like there are options, as you were pointing out. You can get standalone racks if you don't have chilled water. If you need, if you integrate with chilled water, great. But it really is a matter of considering where are you headed and what are the devices and the densities that you're going to be running.
Yeah.
I guess it's one of the things we keep kicking around. I mean, again, talking with John Abbott about availability. Maybe the hardest problem is actually getting a hold of some of these high power devices. So if you can find enough Grace Hopper chips to be able to do what you need, maybe that's your first order of business. But
yeah, that's
we'll
realistic. Yeah, that's right.
Yeah. Challenges either way. But again, it is one of those things that we are moving into a world in which density really is their principal concern. And with it comes a lot of those power dissipation concerns. Mm-hmm. And ones in which you can start to dissipate that power in ways that are continuing a lot of the focus on sustainability that's out there. Because again, that's traditional air cooling has got limits. You should at least be keeping your eyes open to see what's available when you look down the road.
That's true. Yeah. Simple as that is that we're getting close to the limit of air cooling. That's it.
Oh, well, good things to keep in mind. Well, this has been great. Thank you, Perkins. Appreciate all the perspectives and the insights on what's going on with OCP.
Yeah, my pleasure.
It's great having you back on the podcast, and clearly more discussions to come. But we are at time, and that is it for this episode of Next in Tech. I want to thank our audience for staying with us, and thanks to our production team, including Carolyn Wright and Caitlin Buckley on the marketing and events teams, and our agency partner, the 199. We're going to be taking a pause over the New Year's. So this is our last episode of the year, but I hope you'll join us in the new year where we're going to be talking about sports licensing. There's been a lot that's going on towards the end of the year, a lot of discussions about some very big potential transactions, and bids that are going to be coming in around everything from soccer, football, American football, all sorts of things that are happening. So I hope you'll join us then, because there is always something next in tech.